utilization of e-waste and plastic bottle waste in concrete. Now to start with, I just conducted a survey in my own university to find out the amount of plastic bottle waste which was produced. So it was 46% of the plastic bottle waste that was produced from the our college. So we strictly need to take some of the actions to utilize this waste. This was some of the condition that the plastic waste was burned or it was laid away like this. So the waste collection. My study is based on the collection of the electronic waste and the plastic waste, grinding them into the small particles so that they can behave as a fine aggregate in the concrete. So for the collection of the e-waste, I just collected the e-waste from the local electronic shop, and the plastic bottles were collected from Nirma University itself, and a homogeneous mixture of 2 kgs were prepared by grinding this waste. Now in this photograph we can see that the electronic waste was generated from the keyboard and electronics items. It was grinded into smaller particles which were less than 4.75 mm. This is the scrap grinder machine. The bottles of the cold drinks and the bottles of the Bisleri bottles were grinded into small particles. The non-used CDs were also grinded to form a waste now the particles which were grinded were again processed in the friction roller machine. Now the problem with the grinded particles was that the particles were shiny and they were more of a round shape. So we need to just roll them against each other so that they may break, and plus they will develop a roughness on the surface which will help them to bind with the cement. So this was the first preliminary machine which was fabricated by us. So it has an hopper, and it contains motor which contains 2 friction plates in which the waste just comes and grind between the 2 plates, so it breaks, and it's also develop a rough luster. In this photographs we can just see the difference between the 2 waste, that the first this was the waste, and second we just processed it, so it become rough, and plus the particle was also divided into small particles. So we just sieved the mixture, and we get we get the grinding capacity up to 600 micron. So we tested the physical properties like the specific gravity and the absorption. So the specific gravity was found very less for the crushed plastic bottles, and the absorption was very less in the case of e-waste and the crushed bottle waste. To test the strength, we just made a mortar mix. We made a mortar mix of 1:3, and we replaced the fine aggregate by 0, 2 and 4%. These are the photographs of the actual preparation of the mortar cubes and their testing. And the second use we found out in the form of a decorative material. E-waste has the characteristics that it glows, so we use this property to make some of the tiles or decorative tiles which can be used in our houses. It has many of the benefits, like it gives the exposed surface an aesthetic look, it checks the crack propagation, it assures less maintenance, and as the grinding waste has a shiny texture, thus they can be applied on wall with putty, and they can make the wall more reflectory, so it may add to the energy saving. Now these are the various examples of the tiles which I made. They were made with both CD waste, electronic waste, bottle waste, or alone crushed electronic waste. So these are the results. I just worked with 3 of the mixtures. First mixture deal with the electronic waste which was grinded. Second was from the crushed plastic bottle waste, and third was the electronic waste which was further grinded by rubbing in the rolling machine that we made. So The result of the first the proportion of the e-waste, as it was predicted, the compressive strength falls down. This was because of the electronic waste. The grinded electronic waste is not a cementitious material, so it does not bind with cement. So mixing it with a higher proportion reduces the packing density and thus the compressive strength. And we can see with the crushed plastic bottle waste, the strength which has subsequently reduced. It was because the particles have the flaky nature. The particles of the bottle waste are flaky, so they do not bind well and highly reduce the packing density and thus the compressive strength. Here we can see the graphs depicting the same. This is with the plastic bottle waste. Now our main concern of the project was to just regrind them by applying some of the friction and friction between the particles and just testing it again. So we with the help of NA Industries, we just sieved, we just grinded the waste and added in the mortar with 0, 2%, 4%, 6% and 8%. So from the graph we can see that as the 0 at the 4%, the strength is gained, and after 4% the strength reduces. So from the overall study we can conclude that the strength slightly reduced in the case of grinded e-waste. So this can be used as a replacement of fine aggregate. And we also concluded that the strength varies with the size of the particle. And in the case of the bottle waste, the strength reduces up to 12% at the 28 days. So the plastic bottle waste can be used in some of the structures, like making of the paver blocks, where subsequent strength is not required. And it can also be concluded that 4% of the electronic waste aggregate can be incorporated as a fine aggregate replacement without any long-term demeritable effects. Making the tile with white cement and crushed e-waste were 20% cheaper than the vitrified tiles of the same dimension. And in the future work we will be casting specimen for the testing of the flexure strength and the tensile strength for various composition with the electronic waste, plastic bottle waste, and more emphasis will be given to grind the waste into more fine powders and apply the gap gradation in such a way that maximum packing density can be achieved. More variety of the tiles will be made so that it increases the popularity among the common masses. These are my references. Thank you.